operation, we can use a simple perceptron to work for the AND operation. Guys, look at this. If we have x1 and x2 and we have the output like this, the AND operation will be if the true is 1 and false is 0. So x1 is 0, x2 0, x1 0, x2 1, x1 1, x2 0, x1 1, x2 1, and the output is negative, 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 and positive, right? Or if you think that if the summation of the input is greater than 0, it will be 1, the output. So if not, it will be 0. So you can think that this one will be 0, 0, 0, and 1. It depends on your setting. Okay, so if we plot a graph here, if this one is x1, this one is x2, you can see that for our data, this one is the negative class, this one is the negative class, this one is the negative class, and this one is the, sorry, I'd like to change the color a moment. This one is negative, 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 and this one is the positive class. Okay, and this one is 0 and 1, 1. So guys, let's get back to our equation. So in this case, we have x1, x2. So I would like to introduce this one, w0, x0 plus wi xi plus w2 x2 must be greater than 0, right? So x0 is always 1, so it becomes w0 plus w1 x1 plus w2 x2 greater than 0. Your task is you have to find the parameter setting like the one that we did in our hypothesis representation in the first part of the introduction to the machine learning. So it's quite easy that you can find W0, W1, and W2 that make these example to be correctly classified by this perceptron. So guys, I think that you can compare this equation W0 plus W1 x1 plus W2 x2 is the same as the way that you did with ax plus by plus c. Is the same. Do you recognize something? Yes, actually. This one, if you change x1 and x2 to be the space of x and y, this is the linear equation, right? Or if you compare with 0, the approach that you have to do is you have to find the line ax plus by plus c is 0, right? And you have to check which side of line that is positive, greater than 0, or which side of line is less than 0. So this is the way that you can do. You have to find a line that can divide the space into two parts, the positive and negative. So guys, if I select a line, we just particularly select the point 0.5 to be our line, like this. For example, I select this line 0.5, 0.5. From your expertise on the linear equation, linear system, what is the equation of this line? Actually, you can think that this one is x plus y is 1.5. Or in the space of x1 and x2, it should be x1 plus x2, that is 1.5, right? Right. So if you want to change the format, the patterns into this format or this format, how can you do it? You can do it in two ways. Sorry, I'd like to move this equation to here. So we will be able to change it. Okay, I draw a straight line here. So we have two ways that you can do. That is, you can move 1.5 to this side or move x1 plus x2 to this side. So that is 1.5 plus x1 plus x2, 0, right? And the same way, minus 1.5 minus x1 minus x2 is 0, right? But the way that you have to compare is you will check that the summation of all terms greater than 0 or not. So let's check. We can compare using this table. If you have x, I will copy the x1 and x2 and minus 1.5 plus x1 plus x2 greater than 0 or not, and 1.5 minus x1 minus x2 greater than 0 or not. 0, 0, 0, 1, 1, 0, 0, 0, oh sorry, and 1, 1. So if you replace x1, x2 by 0 and 0, what did you get? You will get minus 1.5 greater than 0, right? That is false. Or negative. How about the second one? x1 is 0 and x2 is 1. So the left side is minus 1.5 plus 1, right? So it must be 1 minus 0.5 greater than 0. That is false. For the next one, x1 is 1, x2 is 0. So it becomes minus 1.5 plus 1 plus 0. So it will be minus 0.5 greater than 0. That is negative 1. The last one, if x1 is 1 and x2 is 1, the left side will be minus 1.5 plus 1 and plus 1. So the summation of all three terms are 0.5 greater than 0. That is positive. Correct. Right? How about the right one, the last column? If you replace x1 and x2 by 0 and 0, you will get 1.5 greater than 0, right? So it will be positive 1. If you replace it by x1 is 0 and x2 is 1, what did you get? You will get 0.5 greater than 0. That is the positive class. How about the third one? If you use x1 to be 1, x2 to be 0, it will be 1.5 minus 1 minus 0. So it will be 0.5 greater than 0. That is positive. The last one, if you use x1 is 1 and x2 is 1, 1 and 1, 1 here and 1 here. 1.5 minus 1 and minus 1. So it will be minus 0.5, right? Greater than 0 is not. So it's correct. So can you see? Now you have two sides of the operation, right? So now you can select the one that is correctly classify all n examples. So it will be this weight, right? So your weight, W0, W1, W2 will be minus 1.5, 1, and 1. Okay. So guys, let's pause the video and try to find the perceptron, the weight of the perceptron that can find the OR operation, that can work for the OR operation. So I think I'll end this video clip here, and in the next video clip I'll show you the solution. See you guys in the next video clip.